Whenever. I'm ready to go. It's 10:40. Let's hit it. Okay, ladies and gentlemen, boys and girls, children of all ages, my name is Larry Hastings, and this is Solve Your Problem with Sloppy Python. Can I get my slides on the screen, please? Thank you. Yeah, I don't know what happened. If you don't like data visualization, this is the only other talk, so welcome to the room. So, ladies and gentlemen, boys and girls, I dare you to write some sloppy Python. Now, what I'm talking about here is personal automation. I'm not talking about code that you're writing in a professional context. I'm not talking about code that you're going to check in. Well, maybe you'll check it in. But often it'll be throwaway scripts you're never going to keep. And this is not code that's going to be reviewed by anybody else. This is code that you're writing for yourself, and you're the only person who's going to be using it. And guess what? You can cut some corners and write some crappy code and do some things that are really questionable, and it's totally fine. No one will ever see it. No one will ever know. So the fundamental thing you're trying to do here is to solve your problem. There is some task, something that you're doing at the computer, and you don't want to do it anymore. You want the computer to do it for you. So when I'm doing that, generally I want to get from, I have a problem, to, oh, the problem has gone away now, in the shortest possible time, the shortest possible distance. And that means doing things often in a simple way and a really dumb way, and you'd be surprised at what you can get away with. So in the talk, I'm going to go over some techniques that I've picked up over time. I'm going to show you some examples of specific problems that I've solved using the techniques. And I'm going to show you some tips and tricks that I've picked up along the way that'll help you cut some corners. Specifically, there's going to be a deep dive into one problem that we're going to solve together. And then we're going to kind of take a survey over a bunch of other programs that I've written over time for this personal automation stuff, because I do it all the time. So when I was writing this talk, I was like, rules? Man, there are no rules. Yeah, but there are rules. There's only 3, and they're kind of important, but they're easy to stick to. First, fail early and noisily. I think this is really the most important point. This personal automation, what I'm doing is I'm writing a script that's going to do the work for me, but it doesn't tend to take very long, and it tends to be kind of crappy code, and so I keep an eye on it while it's running. So, like, if it fails, I want it to fail, like right now, right in the middle of what it was doing, so I can see what was wrong and fix it right away. I don't want it to fail, and then it keeps going, and then it's not clear what exactly happened. So fail as soon as you know that there's a problem, and just give up. Give out a stack trace, anything you can do to stop the process. I want you to stop writing shell scripts. Ladies and gentlemen, shell, thank you. Look, don't applaud, I don't have time. Okay. Shell is a terrible language. Python is a wonderful language. We're Pythonistas. You love Python so much you came to a conference. Why are you writing things in other languages that are crappy? Every time that I'm writing, I'm like, oh, I need to write a shell script. And I write filename.sh, I stop, I sigh to myself, I backspace, and I write py. And every time it's a better decision. I've never regretted this policy. Finally, have some fun. Again, you're doing this for yourself. If you're hating doing it, don't do it. I'm not going to make you. Look, nobody's going to judge you. Nobody knows. Okay. Now, these are guidelines. These are not strict. The rules we've established, you really got to stick to those. These, it's up to you. Again, I'll never know. I think you should use the latest version of Python. Every time, it's always the best version of the language. 3.6 has F strings. If you're not using F strings, what is wrong with you? Where has your life gone wrong? Try automating things even more. And what this is kind of a guideline, as a mantra, I repeat to myself. If I'm automating a task and it gets to a certain point, it's like, and now I have to do the manual step, I'm like, okay, can I automate that bit too? How far can I push this? You'd be surprised at what you can get away with. It's really strange. And I've automated things I was like, I'm never going to, oh wait, I could do this really stupid thing. Oh, the stupid thing worked. Okay, let's move on. This is an opportunity for you to use some new libraries and technologies. And this may not be particularly appropriate. I solved a problem using PyUV. It was like the 3rd revision of a script I'd already been writing. And PyUV is this asynchronous programming library. It wasn't really that appropriate. It would have been easier to solve it with, I don't know, threads. I needed to watch processes that exited. And I was like, well, great, I can use PyUV. I shouldn't use PyUV, but I wanted to learn PyUV anyway. So I was like, sure. Again, no one will ever know. No one's going to judge you. And finally, I want you to do what feels good here. This is an opportunity for you to break the rules. Harry, close your ears. If you don't want to write tests, don't write any tests. If you don't want to do PEP 8, don't do PEP8. Have a 160 character line. I don't care. No one will ever know. So we're going to start with our deep dive, and the problem we're going to solve is a mass rename. We're going to rename a whole bunch of files. And it's really not that many. It's 60 files in this example. So I like old-time radio shows. You remember the the scripted radio dramas they had on the radio from the 30s to the 50s? Maybe you don't remember them when they were on. But you can download all of these things off the internet and listen to them. These are files from a radio show called Rogues Gallery. And Rogues Gallery is a detective show. The detective, Richard Rogue, in every episode, he falls asleep or he gets knocked unconscious, and he floats up to Cloud 8, where a tormentor named Igor, which is Rogue spelled backwards, mocks him in a high-pitched voice and tells him clues that he needs to solve the case for that week. Old-time radio may be a little weirder than you suspected it was. Now, these file names are crap. And the problem is, you can download these for free, but the people who make these collections, they tend to be a little bit older and they're not so computer savvy, and so I don't know what they're doing. Any file system that could handle a file name this long could handle a file name with spaces. So why did they boil all the spaces out? I don't know. But I want to rename these, and I could use a mass renamer like, I like QMV from Rename Utils, but I still would have to go over every single line and add spaces in front of all those capital letters. And I thought, hey, let's use this for the talk. I'm going to write a script that is going to do all the renaming for me automatically. So we're going to take a little side trip here and talk about hardlinks for a minute, because I worry you kids these days. You've never heard of what a hardlink is. If you know what hardlinks are, check your email for the next minute. So we are familiar in Python with the concept that objects and variables are separate things. Variables are really just a name that points to an object. So here's an object. It's a tuple. It contains 1, 2, 3. And if you said number equals tuple 1, 2, 3, then we have a name, numbers, and it points to the object, which is the tuple. And you could, if it was a mutable object, then you could modify it, and numbers would see the update. And you could assign it again to a different thing, and now we have two names for the same object. And if you updated that one, then everything would update. Guess what? File systems in Unix behave the same way. I don't think this is true on Windows. Don't ask me. Ask Steve Dower. He's here. I don't think they support hard links in this way. But file systems on Unix have the same concept. You can have the contents of a file, and then you have a file name that points to it. And guess what? You can have a second file name that also points to it. It doesn't have to be in the same directory, even. It needs to be on the same file system. That's the restriction. So, and if you modify this file, both of the file names will see the updates. So we're going to use this to our advantage. Let me walk you through real quick. I'm going to show you what it looks like. Let's, again, this is all going to be under Unix. That's all I ever use. You touch a file, and we're going to list it. And guess what? If you've been looking at the output of ls-l for years, this is the hard link number. It's been staring you in the face all this time. That's what that column means. There is one link to the contents of this file. So we're going to create a second one. The command line utility that creates hard links for you is called ln. And again, you might be familiar with symbolic links, and that's ln-s. You use that all the time. Well, the original point of the utility was to create hard links. So we're creating a hard link from the contents of the file x to a new file name we're calling y. And now we do an ls-l. And we have x and y, and both of their hard link numbers are 2. So the idea here is, when you're going to do a mass rename like this is an easy way to make a backup for yourself. I used to, when I was going to make a rename a whole bunch of files, I would copy the files to a backup directory. And then I realized, why am I copying the files? Just make hard links. So you could do this step in Python, but I don't bother. Like, there is os.link that creates a hard link for you in Python. But don't bother. Just do it in the shell. It's the easiest thing. Make a backup directory, and then iterate over the files in the directory. You're interrupting, young man. You iterate over the files, and then you just hard link into the backup directory, and now you have backups. If you screw up the file names in the middle of your process, like they're half-baked, some of them are renamed properly, some of them are screwed up, some of them are the originals, you can just delete them all and recreate the hard links back in the original directory, start over, and fix your script. So now we're actually going to start automating this. Step 1 is we need to get the file names into our Python process so that we can modify them. And you might be thinking, okay, we're going to use glob. Well, actually, we're probably not. Because here's the thing. We just created that backup directory. And if we create a Python script in that directory, now we have the Python script. And we would need to filter those out of the output. And you know what's just easier? This list of files isn't going to change. It's been the same for probably years. we're just going to cat the contents of ls into our Python script and then throw triple quotes around it, and now we have a giant string that contains all the file names. And I do this all the time. And you just edit this, and you like remove the backup directory, remove x.py, and you're ready to go. Now this is one giant string, we need to break it up. So I'm going to teach you guys some string manipulation functions built into the string object. The first three, lstrip, rstrip, and strip. These remove whitespace from a string. lstrip removes the leading whitespace, the left whitespace, returns the result. rstrip removes the trailing whitespace, returns the result. Strip removes it from both ends and returns the result. And if you give any of those functions a string that only contains whitespace, all of them will return an empty string. The other thing we need is called split. Split takes a single string and breaks it up and returns to you a list of strings, where every time it found the string you passed in, the separator string, it breaks it into two pieces. If you don't pass in a separator string, it breaks it up by whitespace, and any amount of whitespace is equivalent. So here's what I do every single time. I just add .strip.split at the end. And I split by lines, and now we have a list of all the file names. And you might be thinking, why do I need that strip? And the answer is because there's these two end of lines here that leaving them there makes it easier to work on this list of files. But if I leave them there in the actual output, then I'm going to get an empty string at the beginning and the end of the list. Now I have to filter those out. So it's easier to just remove it right there. .strip.split, again, this is an idiom I use all the time when I'm doing this sort of work. Now, it's time to start dissecting these, because now we can iterate over the list of files and look at each one in turn. So here is an example file. And if we look at it a little bit, okay, we can probably carve this up with just slices. So this is the date. This was from October 25th, 1945. I'm going to add the 19 on the front. I don't like the just 45 by itself. This is the ordinal number. This is the 19th episode aired. And I don't know why they have a hundreds digit. There were only 72 ever made. The last one was made in the 50s. There aren't going to be any more. So I just throw away the numbers digit. I only grab those two. And then this is going to be the title of it. It's just the rest of it. So this is what it looks like so far. The problem with this, of course, is that we didn't remove the .mp3, and we want to remove that. So this brings us to our next string operator. Our string method is called partition. Partition, you give it a string, and it returns to you three strings. Everything up to the separator itself, and everything after the separator. Our partition does the same thing, but it's the last instance of the separator string instead of the first one. And if you pass in a separator that does not appear in the string, it still returns to you three strings, but now the first string contains the entire original string, and then you get two empty strings. So this looks like this. Oh, I want to say, by the way, I think this is a really elegant API. It's really nice and predictable in a lot of ways. And for one example of that is, every time, it doesn't matter what the original string is, it doesn't matter what the partition string is, whatever you use, you get before, step, and after. If you add them back together, you always get the original string back. It's nice and predictable. So here are a couple of examples of partition in use. If we have a space in the thing and we partition on space, then we get three strings, before the space, and after. If we partition on a dot that doesn't appear in the original, we get the original string and then two empty strings. And again, because it's so predictable and it's so easy to use, if you partition our partition on the extension of the file name, and then you just bracket 0, you just grab the 0th thing from the list, you always get the file name with the extension clipped off. If the extension isn't there, you'll get the entire original string. So this is a really safe operation to throw away extensions. I never use, os.path.splitxt. Yeah, who needs it? It's really just doing this anyway. So another tip, I kind of like to test as I'm going along, so I get part way, and then I stop, and I print out what I've got right now, and see how it looks. So this, right now, looks like this. These are the dates look good, the ordinal numbers look good. Now it's time to deal with these lack of spaces in these file names. All I need to do, really, is look for the capital letters and add a space in front. So here's what I did. I just iterate over it. So first of all, I throw list around the title. That takes the input iterable and breaks it up into individual elements. So now we have a list that contains single character strings, that contains the entire title of the program. And then I enumerate over it, so I also get the ordinal number of where that character appears in it. And I look at the character, and if it's uppercase, I add a space in front and put it back into the list. Then I join it back together, and then I strip to throw away white space, because we just added a white space character because the first character was an uppercase character. And now, you're probably thinking, why didn't you use a list comprehension? And the answer is, I don't know, this was harder to write. I had to sit there and think for a minute how to write the list comprehension. This was dead easy to write. I usually just do it like this. Again, no one's going to judge you. Do whatever feels good. And if you want to practice your list comprehensions, do a list comprehension. I don't care. So things are looking pretty good now, but there's still one more problem. Again, they didn't like spaces. They didn't like apostrophes either. And there were a couple other words that didn't break up properly. And so there's one more string function. This is the last string function I have to introduce to you in the talk. It's called stir.replace. Stir.replace searches for instances of old string in the string and replaces them with new string and returns the result. And so what I do, again, this is an idiom I use all the time. I think of this, I call this an exception list. This is a tuple of tuples of replacement, search and replace strings. So I just iterate over these, and for every single title, I do all of these replacements. Most of them don't fire every time. This is really slow. Guess what? We don't care. It's fine. You're not performance sensitive in this sort of automation. So now, everything looks pretty good, and actually we're basically done. All we need to do is format the file name and do an os.rename, and we're done. You could use shutil.move, and that's more sophisticated. That can move files across file system boundaries and things. I usually don't bother. I can remember how to spell os rename. So that's the end of our deep dive. Now we're going to talk about the more sophisticated scripts that I've written over time, and we're not going to look at all the source code for those. So the first one's provision, and like I said, by the way, I have 10 minutes left. I'm really going to go fast. Provision is solving this problem. So I have a laptop, I have a backup laptop, I have a desktop machine, I have this cool desktop replacement laptop that I'm going to use at the sprints, I have a server, I have a home theater PC. All these machines are running Ubuntu, and I reinstall every 6 months because I like to run the latest version. I don't trust the upgrade installers. I always install from scratch. And that means I have, every 6 months, I have like 8 or 10 machines that I've installed from scratch, and they don't know anything. And I need to configure them to make them comfortable for how I like to use them. So that's what provision is for. Provision is literally the first program, well, it's the second program because I have to SEP it over, but it is the first program I run that runs on the new machine, and it configures everything the way that I want it. So what does it do? It installs 140 plus packages, including Sublime Text, which needs its own PPA, and Chrome, which has its own funny deb that it wants to install. It installs my known keys for SSH so that I can just SSH places and I don't have to type my password. It installs my fonts. It installs my to-do list and my personal data, which are synchronized using Mercurial. It configures tmux and zshell the way that I like them. It configures Nemo as the default file manager because I hate what they're doing to Nautilus. It downloads and builds the current Python 2 and Python 3. It literally goes to python.org/download, scrapes the page, uses a built-in HTML parser that's in the Python standard library, finds the tarball for the current version, downloads that, decompresses it into a directory, runs configure, make install for 2 and 3. And then it also downloads the Python documentation and pops open a web page on the library page so I can hit bookmark and put it in my toolbar. Now I'm ready to use the machine. Just to give you an idea of how crappy this code is, here's how I install packages. I pass in all of the packages I want to install, and I take that, I join it together, I create a command line, and I call sudo apt-get install -y, say yes, here's your list of packages. You know what? I tried that, and it worked first time. Like, why are you writing shell scripts? This is so easy. It gets weirder. Here is how I install Sublime Text. So @app, that's a decorator that installs packages for me. Those are preconditions for this thing. And it's really just a convenient way so that I'm not constantly installing packages all the time. I like collect them all at once and I install them all at once, all these preconditioned packages. Then Sublime, what I do is I look and see, is it installed? Okay. Is the license file installed? And if it isn't, then here's the second part of the function. I download my license file from one of my servers, and I cat it. I run a system shell, I cat it, and pipe that into xclip selection-c. So now my license is on the clipboard, and I run Sublime Text. The first thing it does is pop up a dialog, say, hey, enter your license key here. I press Control-V, I hit Enter, and I'm done. I can't automate this because Sublime Text wants to like encrypt it and put system information on it itself. So it has to be a manual process. But that was as far as I could push it. Now, I'm not going to upload this anywhere because Provision has a bunch of stuff in it that I don't want to share. It'd be a lot of work to make it like clean for all of you. But there's a kind of a similar script I wrote last year. I was part of a team writing a video game in a week for something called PyWeek, We wrote a game, Dan Pope and I, called My Sincerest Apologies, and it's a real bear to get it installed. But on Ubuntu 17.10, I wrote a script that just does all of the work for you. So if you go to GitHub, go to Larry Hastings, PyWeek 24, you just download this one script, install My Sincerest Apologies on Ubuntu 17.10. You run that, it's going to install all these weird dependencies and things, and you're ready to play the game. It's worked every time I've tried it. So, moving on, DCamp. I have a problem. I like buying music from online services. I don't like streaming. So I go and buy FLAC files from Bandcamp and CD Baby and Google Play Music, which only sells MP3s, and HD Tracks, which are these crazy high-resolution files. And they give you a zip file that contains a bunch of file names, and these file names, again, are crap. I got to change them. So this is what Bandcamp looks like. Google Play Music likes to put them in subdirectories, which is a pain. I don't want those. CD Baby has these terrible file names that, again, don't contain spaces. I don't understand people. This is what I want it to look like. This is how I'm used to it from Winamp in the 90s. It should be name of the track, name of the artist. There should be an MP3, or excuse me, a playlist file, an M3U file that contains the files in track order. So first thing was I had to go and find a Python multimedia tagging library that I liked. This is the one I settled on, taglib. It's just Python bindings for a C library that's really old and mature and well debugged. And I just started writing a script. So I wrote a script called decant Bandcamp, which takes the files from Bandcamp and decompresses them and sets them the way I want. And then I was like, okay, now I got to hack that up and make one for CD Baby. So I copied it and just renamed it, and then hacked that one up, and now it worked for CD Baby. And I was in the process of doing it for Google Play Music, and I thought, you know what, I'm not really changing these scripts that much. I bet I could write something that would work for all of them. And I did, and it works great. So this is just called decant. What it does is it creates a randomly named directory in the current directory, puts the zip file in there, and unzips it using os.system. It flattens the directory. It removes all of the subtree under the directory and just puts all the files in the root. Then it scans all of the metadata in that file, in all of those files, and makes sure we have enough. We really need track numbers. We need artist names and track names and things like that. And if we have everything we need, then it renames everything. It cleans it up. A lot of people like to use capital letters, like all caps. I don't know why. So I just use title case on everything, and there are a couple of things that title case screws up, like punctuation, like apostrophes. It capitalizes the letter after it. So I have a couple of special case fixes, but that gives me clean artist, album name, and title, and now I have everything I need. I rename all the media files themselves the way I want them. I create a playlist with the files in album order. I rename the directory the way that I want that, and we're done. One last file we're going to look at. Again, I like OldTime Radio. My favorite show is called Yours Truly, Johnny Dollar, and that I actually buy on CDs because I want the cleanest audio I can get. This is 35 episodes on 10 compact discs. These are a little weird. Some of the episodes, there's 2 half-hour episodes on a CD, and those are individual stories. Sometimes it's 5 15-minute episodes, and that's one continuous story from when there was a serial, and it was 5 nights a week. And they're a little bit different, and none of these CDs are ever known to the FreeDB or CDDB or MusicBrainz. So when I run the program to just rip them, I get really terrible file names, and I got to fix up this metadata. Now, again, I could use a tagging program, but it was such a pain to use a tagging program for all these, and I was ripping so many of them. I wrote a custom script to rename these things for me. So the first step was make a custom data file format, because I wanted to make it as easy as possible, as little effort as possible in order to type in the metadata. So this understands what Johnny Dollar things look like. Defaults to 1956, because that's my favorite year. The matter, that's kind of the middle of the title, and the month and the day, and this is 5-part story because it noticed there were 5 files. There's a slightly different template for if there are 2 stories, where it would say like year 1, year 2, month 1, month 2, things like that. It emits the correct template. What it does, it writes it out to a file, and then it runs VI on the file. So that presents the user, me, with an editable thing so I can type in my metadata. And then once VI exits, it slurps it back in, and now we have to parse it. And guess what? We wrote a custom file format. Parsing, it's the easiest thing. I'm serious. All you need to do, create a dict, and then we're going to iterate over the file. Again, it's strip.split, just like we did before. For each line, strip it. And then, if it starts with a hash character, or it's an empty line, throw it away. That's a comment or an empty line, we don't care. Then, it's going to be in the format name equals value. Partition on the equal sign, make sure we had an equal sign, it's a legal line, and then take those 2 values, strip those, because they're going to have leading and trailing whitespace probably, and just set it inside of the dict. Guess what? We just parsed a custom metadata file format. And we're done. At that point, all we needed to do was fix the metadata, because we've already got it. I typed it in, rename the files, write the playlist, because it didn't write a playlist, for the 5-parters, put it in the correct directory where I store my OldTime Radio, and we're done. And that's actually the presentation, except there's one more tip. You know how I've been showing you os.system on all these slides? You have to stop using it. And the reason is, I told you at the beginning, you have to fail early and often. And while I was writing this talk, I realized, you know what, os.system is not failing early and often for me. os.system, if the program that you run fails, then it just keeps, it says, oh, that's fine, let's keep going. You want a program that, you want a function in Python that fails when the program fails. If it returns a non-zero value, then you want to stop, and you want it slapped in your face. So the function you want, again, we're using the current version of Python, it's subprocess.run, and you want to pass in check equals true. If that returns non-zero, exits, throws an exception, you're done. And this is actually really easy to run. Here is the replacement. I can take this function and just paste it into all my scripts and replace os.system with run, and it works fine. You don't have to pass in the list of the arguments. It just handles a string. It's fine. You want shell equals true, so you can do the crazy things like piping and sudo and things like that, and everything's great. And that's it.
Thank you, Larry. We've got a few minutes for questions now, so come to the microphone if you've got one.
Oh, we have time for questions. Look at how fast I went. You
I
probably don't remember anything I said.
I would ask that you use this time only for questions directed at the speaker, though. Please discuss longer questions.
Yeah, we have 4 minutes for questions. Okay.
With speaker after John.
There's the microphone. Right here.
Hi, thanks for the talk. Don't you think that writing code like this teaches you habits that you wouldn't want to
I can't
develop?
understand you. I'm sorry. Can you speak up?
If you write code like this, it teaches you bad habits, which results in bad code later down the line where you really need a good code.
I'm sorry. It's like echoey and stuff. Can someone repeat his question for me?
Read it.
Oh, great. If you write code like this, it teaches you bad habits, result in bad code later down the line when you really need the code. We're all consenting adults here. I don't think it teaches you bad habits. I know, like, you practice your habits and then they become ingrained in you. My point is, again, this is fun, and this is a time for you to take off those restrictions that you normally have at work and exercise that. It's like you're at work and you're like, I wish I could do this. Well, at least you get an excuse to do it at home. I don't think it teaches you bad habits. I think it lets you exercise your bad habits and get it out of your system.
Yeah. Hi, Larry. Have you heard of Ansible?
Again, have I heard what?
Have you heard of Ansible?
Ansible.
Yes.
I've heard of it.
Try it.
That's not Python. What? I'm looking for an excuse to write more Python. Hi.
So as a data scientist at work, like, I end up like doing a lot of stuff like what you do in order to like manipulate my data and things like that. So how do you decide when you go from writing a script like this to, like, making it a process? Like, how do your scripts evolve?
How do my scripts evolve? Again, unless I'm doing something like I want to try out this library, I want to get from I have a problem to I've solved the problem in the quickest possible thing. Usually that means the first idea that I have that I think might work, I try it, and if it works, I'm done and I move on. So the scripts evolve over time. If it turns out later, it's like I run it again, I'm using it again. Like provision was much simpler before, and then I realized I really needed individual functions that did individual things, and then those got more sophisticated, and I was installing packages all the time, and so I made the apt decorator. So it just becomes a reaction to things that are dissatisfying about the current solution. If the current solution worked great, then I'm done, and if the current solution is unsatisfying, then I'll go back at some point and reuse it, if I have time.
So, like, do you see yourself like taking a proactive approach to, like, do you see something, some new development in Python or something like, oh, I can refactor this script in this particular way?
Proactive. Okay, again, first of all, no one's going to judge you, nobody's going to care. So if you want to be proactive and you say, you know what, I'm going to write too much code today and I'm going to oversolve this problem. Great, have a good time. Usually, again, when I'm doing this, I want to solve the problem and I want to move on with my life. So I'm not proactive. I do the simplest thing that will work, And by the way, that is good training for a professional context. Do the simplest thing that you think will work, and if it works, you're done. And if you want to be proactive and fix problems that you think might crop up in the future, go ahead. But I don't usually bother. I usually just get my problem done and move on. Okay, I think we're out of time for questions anyway. Thank you all for coming. Bye-bye.